Yeah, all right. Uh, in earlier sessions, we are discussing about the life cycles of the batteries. That is how it is going to be full charge and it is fully discharged. The life cycle will matters a lot for the batteries. All right. Let us see how the end of the life will becomes for the batteries in the especially if we take any lead acid lithium ion batteries, right? It sees the life, the charging and discharging, so that we can predict the life of the batteries. So that is what we have discussed in the previous sessions. uh, we have to see how the life can be decided, which is based on the C rate of these batteries. All right. So what is actually the number of full charge and discharge? If the battery is charged for the 100%, for example, if the battery is charged for the 100%, then it may discharge also. Already, it may discharge also. We have to decide the C rate of the batteries, right? It means we have to study the life cycle of the batteries, how long it can retain, how long it can use a life. For if you take a battery for your electric vehicles, it may be of for your, also if you take a battery for your laptop, also any other devices, right, which is such as lithium ion batteries. We will just think about the life of the batteries, how long it will retain. It may be retained for 2 years or it may be retained for 3 years. That is what it depends upon the life cycle of the batteries. That is what we need to study. What is the life cycle? All right. So the life cycle will always depends upon the number of full charge and discharge cycles, right? How much it has to it will charge for one time, it will charge for the another discharge time. So it will decide, the life cycle will decide the actual retention, or you can say the upcoming days, how long it can retain the batteries. Will decide the life of the batteries, which is based on the life cycles, right? For example, in the previous session I talked about the life cycle of the batteries may be of 2000 to 5000 approximately, right? So what does it mean actually 2000 to 5000? So it means that it may discharge for 2000 time, or it may charge for the 2000 time. So that is what it will tell. After 2000 time, it will go for the degradations. So that is what we have to study in the earlier sessions, right? We have studied the C rate, and also we have to discuss about the C rate. We have to discuss about the lifespan of the batteries, and also we have to discuss about the degradation of the batteries, right? We have to uh, give the life for the batteries. That is how we are going to use the life for the batteries, and what is actually the life for the batteries, how long it can retain the batteries for the longer time, longer durations. So once, for example, once you buy the market, and once you buy the batteries in the market, so usually we talk about the people, that how long the battery can be retained, how long it can the battery can give the life for the next upcoming 5 years or 6 years, right? We'll ask for the guarantee for the manufacturers, right? Or from the buyer will also usually ask the life cycle of the batteries for the manufacturer, right? We want to have the life minimum of 5 years, minimum of 6 years, like that. Then only we are going to buy the batteries, right? Then what is the actually life cycle? Means the battery is going to give retentions, means it will retain for how long it can retain for charging and discharging. What is the charging time and also the discharging time, right? And what is the C rate? That is what we have discussed in the earlier sessions, right? So life cycle will decide the number of fully charged and discharged, right? If the life cycle is around 2000 to 5000, it says that it will charge for 2000 time, it may discharge for the 2000 time. It may charge for 5000 cycle, it may discharge for the 5000 cycle. So that is what the life cycle. After that, it will go for the next stage called degradations. Means there will be the degradations in the batteries, that it may have the any chemical reactions, it may have the degradations of the electrodes. So something, the various factors will occur for the to degrade the discharging and charging for the batteries. Means it will try to decrease. If it doesn't charge fully, it shows it is 100% is charge, correct, but it will not charge fully due to the degradations. So that is what we need to study in our topic. In the exams they may ask degradations of the batteries, how it is depending upon the life cycle and also the state of charge and state of health. So all right, so once the life is gets over, what will happen? That is the end of the life. Means the battery has to be thrown out. All right. So if it doesn't charge properly, if it doesn't discharge properly, for example, if you say the battery is charged for the around 100%, right? When you buy for the first time, right? So it has a certain life, right? It may give life for the next 4 years or 5 years, right? It may charge and discharge for 5000 times. I'm just talking about the battery life. It may charge for the 5000 times, it may discharge for the 5000 times, right? So that after that, the life gets ended. For that reason only, we have to decide how long the battery can retain, it can give the life, right? So for that we need to study the C rate. right? The C rate is nothing but it is the measurement quantities at which the speed the battery is discharged, and also the charge. Right. Here you can see the charging at a C rate of 1 coulomb, right? So the charging at a C rate of 1 coulomb, it says that for 1 hour, right, 1 coulomb of charge, 1 coulomb of charges has been stored for the 100%, right? If it is charged, battery is charged for 100%, it says that the battery is charged for 1 hour. It has taken for 1 hour to charge 1 coulomb, right? For which can use 100% of the batteries, right? Sometimes if it is charged for 2 hours, for example, it takes 2 hours, right? For a same C rate of 2C, for a same C rate of 2C. So all right. So let us say somebody has been entered. I think Uday has been entered. All right. Okay. All right. So it is visible. Rashmi, it is visible.
Yes, sir.
So that is what I was discussing about the charging of the C rate, right? 1 coulomb. If the battery is charged for the 100%, then you can say it has taken time period of 1 hour to charge. Means 1 coulomb of charges has been stored in the batteries. So all right. For example, if it takes for 2 hours, right? 2 hours for the same 100%, right? It means that that depends upon how much of coulomb of charges has been stored in the batteries, right? So that will decide the C rate. Actually the C rate is the charging at C rate of 1 coulomb. I will just show you very clearly that how the battery can be charged. In the previous session already shown. All right. So where it depends upon the charging and discharging of the batteries for the specific time periods, right? If it is taking for 20 minutes, right? For it is taking for 20 minutes, it may be of 5C. It may be of 5C, right? If it is taking for 10 minutes, right? It may be of 10C. The C rate of the will be around 10C, right? If it is taking of 2 hours, right? It may be of C by 2. All right. So if it is taking for 5 hours, right? It may be of C by 5. The charging rate will be the C by 5. So that is, it means it, if the more the time it takes, the more the time it takes, the more the charging will be the different, right? The charging will be the different. That is called, we call it as a C rate of the batteries, right? So this is one of the best example. If it doesn't maintain this, suppose if you don't maintain the charging rate properly, all right, if you make the fast charging, if you make the very slow charging, it depends upon the battery life also. So meanwhile the temperature will also increases, right? So we have to maintain the constant temperature while charging and discharging of the batteries, or else we have to monitor your all the parameters, your voltage, current and temperature, right? Especially for the especially for your batteries, right? Or else what will happen, the battery of the life may be degrade very soon. All right, the battery of the life will be it will try to degrade as much as earlier, right? So that is the reasons we have to think about how the battery of the life can be retained for a longer durations. So all right, say let us see what is the battery degradations. Battery is going to degrades, right? So what is the meaning of battery degradations, right? So it is not giving the enough life. So once the battery is been under the natural irreversible process, right? So where rechargeable batteries loses its maximum energy. So then we can say the battery is under the degradations, right? So it means that battery is not able to charge properly. It is not able to discharge properly. So that is what the meaning of the battery degradations, right? The irreversible process which is happening, right? Where a rechargeable battery loses its maximum energy capacity and performance over the time. So that is what it will not do performance as like it was doing the earlier. So that is the reason for the degradation. For the degradation, there is a lot of reasons are there, right? We have to understand the battery meaning of the battery degradations is it is irreversible processes, right? Where a rechargeable the rechargeable battery is not able to do the perform well as like earlier, right? So it is losing its maximum energy capacities, right, for charging and discharging, right? That is what we are talking about the C rate. It used to measure the speed at which the battery is charged and discharged, right? So for 100% discharge, if it is taking up 1 hour of time, for that would be your C rate, right? For it is taking the for five almost the 20 minutes, right? The charging rate will be very higher. If it is taking the more time, the charging rate will be very less. So that is what the C rate will try to decide the life cycle of the batteries. Also, while charging, we have to look up, we have to see how the battery can be charged in a very nominal way, right? For maintaining the temperature and your voltage and current, all the three parameters, right? That is what we look in the state of charge. That is what we are going to study in the third module, the third chapters. All right, that is a battery management systems, right? We have to maintain the battery management. We have to monitor your voltage, current, and temperature, right? So meanwhile, we'll understand the degradations of the batteries, right? If we don't charge properly, or if the battery loses its actual performance, right? Supposed to charge for 100%, right? And it is not able to charge, and it is not able to discharge properly. It means that the degradation is started. Right. So what is a degradations? Is a gradually process by which a battery is ability to store and deliver the energy decreases. Right. The battery is not able to store the energy properly. It is not able to discharge properly. Right. The charging and discharging means what we discussed about the life cycle. Right. What we discussed about the life cycle in the earlier previous slides have been shown the life cycle. Right. So number of full charge and discharge. It is number of full charge and discharge. So how long it will take to charge and how long it will take to discharge the battery conditions, right? So if it is doesn't mix properly, then the life will gets ended up. So that is what we have to see the battery charging and discharging parameters. All right. So we have to see how the battery is charged and how it will discharge. The life cycle is around 5,000, for example, 5,000. If it is not maintaining the 5,000 of life cycle, it means it is about to reach its life cycle. Then obviously the degradation will happen. So all right. So it is nothing but the degradation is just like how the people have during their from the age from the if you say from age 20 to like 50, 60, right? After that, what will happen? The human beings, the bones will get almost try to not having in much strength. Yes, sir, they are going to lose its strength. So likewise, in the batteries also, it will try to lose its actual strength. Let us see what are the parameters it is going to lose its strength to reduce the life cycle from the 5,000. Actually, it has to give 5,000 cycles, right? It is not able to give now. After 5 years, so that is how it is going to make the degradations, right? Where let us see how the degradations will happen, right? The meaning of degradation is the actual gradually process by which a battery ability to store. Suppose it is ability to store, but is not storing now and not delivering energy decreases. It is not able to deliver energy also. It is not able to charge properly also. It is not able to discharge also. So that is the meaning of the battery degradations, right? So this can be result in a device, right? It may be in your any other devices or vehicles which can reduce range, energy, capacity, power, and overall efficiency, right? If the battery is reduces, for example, battery is actually the heart of your vehicles, the electric vehicles, right? So without battery, you cannot run. So battery is actually the heart of the vehicles. We have to maintain the batteries. The battery maintenance is very, very important, right? We have to think about the state of charge and the state of health conditions. We have to monitor the health conditions of the batteries, right? Then only it is possible to have the proper efficiency can be increased, and also it will use the performance well in the future days. It will use the proper capacity, energy capacity, and power densities also for the your motors. All right. So battery is nothing but actually it is a heart of the electric vehicles, right? So we have to maintain the battery and it should not be degraded properly. So we have to think more about the charging and discharging and the life cycle and the C rate. So this is very important. In the exams they may ask most of the research is also happening in the charging and discharging, also the state of charge and state of health, as well as in the monitoring of your BMS, the battery management system. They are going to monitor the voltage, current, and temperature also, right? So that to overcome this degradation, right, we have to monitor all these various parameters so that the degradations can be overcome, right? So in the as it discussed about this battery degradation in the most of the vehicles, if you see most of the vehicle, it will try to reduce its range because it is not giving the life. Because if the C rate is reduced, if the life cycle is reduced, the number of cycles it is going to charge and discharge, it is reduced. obviously the range of the vehicle will also get reduced. Means if the vehicle is about to give for 100 kilometers for 100%, right, it will not give now because the battery is about to degrade it, right? The life cycle of the batteries has been reduced enormously. It has been reduced. So due to the not monitoring the battery properly, right? Because the monitoring of the battery is very very important, or else that may result in a vehicle reduce range also, and it doesn't provide the energy density also. It does not provide the power densities also. So these are the various reasons, right? And finally the overall efficiency, overall efficiency will be reduced gradually, right? So this is the reason we should look for the battery management system for not to be degraded, right? It has to give the proper life cycle. Has the manufacturer been designed, they give the actual life for the batteries, right? They may say 5 years it may come, like 6 years may come, right? So meanwhile, if it is not, performance is not well, if your charging is not well, if your discharging is not well, if you are not monitoring all these parameters, if you are not maintaining the various parameters, then the life of the batteries obviously it will go, right? So battery lifetime is the length of the time it will take to meet the demands for any applications, right? So battery lifetime is very very important, right? You have to give the battery life a minimum of 5 years, 6 years, 10 years, like that, right? You have to increase the battery life so that we have to see how the degradations will happen. We have to work on from the degradations, right? So especially in the EV application, the battery life is very short compared to the other components, because in the EV applications we are using the batteries, because battery is the heart of the electric vehicle, right? Battery is the only one reasons, right, which can provide the can run your entire electric vehicles, right? Without the batteries you cannot run the electric vehicles only. That's why it is a heart of the electric vehicles. All right. So let us see battery. Actually, in the case of EVs, it costs as much as the 30% of the total price of the vehicle, right? If you see, the battery cost is almost 30%, right? Because it is the heart of the vehicles. Because we cannot have if you don't have the batteries, you cannot run the electric vehicle. Because if you have the fuel, in the fuel, for example, if you have diesel, if you have the petrol, right? If you run your IC, you can run your IC engines, correct? So battery is also like if you see in the electric vehicle, the battery is also like a fuel, that it has to, the cost will be obviously it will be more, right? That's why it is as much as 30% of the total price of the vehicles, because the battery will be connected in the module, then the cells will be there, cells are connected in series parallel combination, then they'll make the battery module, then it will be packed, right? So then it will be stored in the actual in the form, right? That's why the battery, the cost will be very high. All right. So it is considerably reliable until it reaches the 80% of the initial capacity, right? If you consider it is more reliable, for example, if you consider more reliable, then the cost may reaches up to 80%. Because when we talk about the batteries, right, when we are not thinking about the C rate, actual C rate of the batteries, we are not bothering about the life cycles, right? We are not bothering about the life cycle. Then the cost, if it doesn't perform well, right, obviously the cost will be reduced. It will not reach to the 80% of the actual initial capacity, right? We are expecting to have the more power densities and more life and more C rate and more life cycles of the batteries, right? So then only the battery cost may reach to the 80% actual price of your vehicles, right? For time being only we have the 30%, right? If you improve the quality of the batteries, right, to not to be degraded very faster, right? So every life every battery has its own life, right? But at least try to improve for if it's giving for 5 years, right? If you manufacture the battery cells, right? Try to improve by adding certain kinds of the composite materials to increase the life of the batteries, right? We have to go through improving the life of the batteries for next 1 or 2 years. If we're giving the life for the 5, then try to give it for 1 more or 2 years so that the everybody will buy your batteries. All right. So we have to think about not to go for the degradations and try to work on from the batteries, right? So degradation is one of the limiting factors in the battery lifetimes, right? And must be reduced in order to extend its lifetime. So that is what we should think about the degradation. So degradation is very, very important, right? It is major factors. If you think we have to limit these factors, or else the life of the batteries will go. Correct. So because when you manufacture in the batteries, it should not start making any kind of the sense like short circuit. It should not gets heated up. It should not make any burning sensation when it gets heavy loaded. It should not try to have any kind of the fire. It should not have it. These are the various dangerous hazards. So that you have to work on from this from the batteries, right? So that's why degradation is the degradation is one of the limiting factors, right? You have to limit these degradations, right? And the battery in the battery lifetime, right? Or else the battery life will obviously it will try to reduce. If you are giving for 5 years, no, it will come only for 2 years. So that's why we have to think more about the battery life also, right? And must be reduced in order to extend its lifetime, right? Degradation has to be reduced. The word degradation says we have to reduce in order to, if you want to increase the life of the batteries. So, all right. Next, we'll see the capacity fade and the power fade, right? So, these are the two major factors, right, which access the level of the battery degradations, right? So, what is the capacity fade actually? Capacity fade will refers to the reduction in storage, right, and of a cell due to the degradation. It deficit the decline of the EV usable range. So that is what it will think about the how the battery can be retained, can be stored for a very longer times, right? These are the two matrix levels where you have to think about more about the battery life conditions, right? One is the capacity fade as well as other is the power fades. Right? It is referred to reduction in storage capacity. Means it is not able to store the energy as much as possible in cells. Why? Because there is a degradation in the cells. The cells may not perform well. That would be the one reason, right? And it have the deficit, the declining in the EV usable range also. If that happens, if the cell get degraded, then only there will be decline in the EV usage. Nobody is going to use it. All right. So nobody is going to use your the battery. So that is the reasons. So we have to see how the battery life can be improved, right? So we have to think about more on the batteries, right? So that is the reasons. Please we have to focus more on the battery life, how to improve the life of the batteries, right? We can do a lot of the PBL on this to improve the battery life. We'll go for the checking the monitoring is the battery life also, right? So which will help us to give a lot of opportunities. If we improve the battery life, most of the industries are also looking for that. We have to give the life for the batteries so that the life can be increased in a upcoming days. We can increase the life of the batteries, right? We have to think about the capacity fade as well as the power fade. So these are the two indices where it will help us to increase the life of the batteries, right? So here the capacity fade will tell us the reduction in the storage means it is not able to store the energy, right, and for a longer times, right? So battery has to store. There is a reduction in the total energy, right? The battery can store as it ages. That is called the capacity fade, right? The capacity fade says that it doesn't have that much of capacity to store the energy, right? And also it is because of aging factors. Yes or not? So once you, for example, once you have the age of around 65, 70, right? So you're in the 70, 75 age, right? You are not able to have the much food. So because you may have certain kinds of diseases also, you may have certain kinds of other various factors also, which you're not able to have much food to enough to take the much enough of the food, right? Similarly, if the battery life is also be aged, so due to the age factors, the capacity fade will also comes into the picture, right? It is not able to store the energy much as like earlier. So because of the degradation, the cell is been degraded completely. So due to this, if you don't have if you have the degradation factor, no, the capacity fade factor, then this EV will not have any usageable forms. That EV cannot take up this, right? The battery cannot give the life. Then we cannot expect the EVs to have the more efficiency, right, and the more performance in the EVs also, right? So it will makes a lot of impact. It will try to reduce the range of your the vehicles, right? If the capacity fade occurs, so what will happen actually if the capacity fade occurs in the cells? So it will not try to give the proper usage, the range what we going to expect, right? For example, if you want to run this vehicle with a new the aged cell, if I take the age cell data, no, if I take the age cell data, what will happen? The EV will not have the much faster, means it will not giving the proper range. The EV will not try to provide the EV is not going to try to provide the actual range where it is going to give for 200 kilometers or 500 kilometers. Now the range of that is going to reduced, right? Around from 300 it is going to reduce 150 kilometers. 50% is been reduced. So what we are going to do then? So if it is going to be reduced, we have to replace the batteries. All right. So that is the meaning of the capacity fade. Capacity fade refers to the reduction in the storage capacity. Means it is not able to store the energy. It is not able to store the energy properly because of the aging factors. Because of the aging factors, it is not able to store the energy. Right. So that's why that due to the degradation. Let us see how the degradation will happen in the upcoming sessions. All right. So we have to understand what is the capacity fade. The capacity fade will tell us about the battery is not able to store the energy, actual energy, as like earlier. Why? Because of the aging factors. That is the one reason. Because of the aging factor, it is not able to store the energy. So if that happens, the degradations will come into the pictures, right? Definitely what will happen, there is a decline in the EV usage range. So there will be a reduction in the EV usageable range. It means that EV was earlier used to give the 300 kilometers for 100% of charging, right? Now for the same 100%, you feel that there is 100% of battery has been charged. But now the EV usageable range will not go for 300 kilometers. So it will run only for the 150 kilometers. So that is called the capacity fade. So all right. I hope it is clear for the capacity fade. So is it clear?
Yes, sir. Sir, ಸ್ವಲ್ಪ ಸ್ಲೋ ಆಗಿ ಹೋದ್ರೆ ಚೆನ್ನಾಗಿ ಸರ್.
What do they?
ಸ್ವಲ್ಪ ಸ್ಲೋ ಆಗಿ ಹೋಗ್ಬೇಕಾಗುತ್ತೆ ಸರ್. ಸ್ಪೀಡ್ ಅನಿಸ್ತದೆ ಸರ್ ನಮಗೆ.
ಸ್ಲೋ ಆಗಿ ಹೋಗ್ಬೇಕಾ?
ಹಾ
Okay.
ಸರ್.
Okay. No issue. I'll be very slowly. Don't worry. ಸ್ವಲ್ಪ ಕಾನ್ಸೆಪ್ಟ್ ಅರ್ಥ ಮಾಡ ಸ್ವಲ್ಪ ನಿಮಗೆ ಕಾನ್ಸೆಪ್ಟ್ ಹೇಳಬೇಕಂದ್ರೆ ನಾನು sometimes I'm going to repeat 2 times. I'm giving the different example to make you
ಕರೆಕ್ಟ್ ಸರ್,
understand.
ಕರೆಕ್ಟ್.
ಬಿಕಾಸ್ ಒಂದೇ ಕಾನ್ಸೆಪ್ಟ್ನ ನಾನು 2-3 ಸಲ ನಿಮ್ಗೆ ಹೇಳಿದೆ, ಡಿಫ್ರೆಂಟ್ ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡು ಹೇಳಿದೆ ಅಂದ್ರೆ ಅವಾಗ ಈಸಿಯಾಗಿ ಅರ್ಥ ಆಗ್ಬಿಡುತ್ತೆ.
ಹಾಂ ಸರ್.
ಆಮೇಲೆ ಕರೆಕ್ಟ್ ಉದಯ್?
ಎಸ್ ಸರ್, ಎಸ್. 2 ಸಲ ರಿಪೀಟ್ ಮಾಡ್ತೀರಾ ಸರ್? ಓಕೆ ಸರ್, ಏನಿಲ್ಲ.
ಯಾಕಂದ್ರೆ sometimes you will not be very concentrating. All right, no problem, no issue. So anyhow, the videos will be there. Videos will be uploaded. You can watch it again, no issue. The previous class sessions, what I've been taught, right? The live sessions ಇಲ್ಲ ಅಂದ್ರೆ ನಿಮಗೆ ಆಫ್ಲೈನ್ ಕೂಡ ಸಿಗುತ್ತೆ, ವಿಡಿಯೋಸ್ ರೆಕಾರ್ಡೆಡ್. ಓಕೆ, you can watch it, no issue. So all right, is it clear? The concept of capacity fade is clear?
Yes sir.
So capacity fade will tells about actually energy ಏನಾಗ್ತಿದೆ, ಸ್ಟೋರೇಜ್ ಮಾಡಬೇಕು. ಅದು ಆಕ್ಚುಲಿ ಸ್ಟೋರೇಜ್ ಮಾಡಬೇಕಿತ್ತು, ಅದೇನಾಗ್ತಿದೆ, ಏಜ್ ಆಗಿಬಿಟ್ಟಿದೆ, ಸೆಲ್ಸಿಗೆ ಏಜ್ ಆಗಿಬಿಟ್ಟಿದೆ. ಇಟ್ ಈಸ್ ನಾಟ್ ಏಬಲ್ ಟು ಸ್ಟೋರ್ ನಾವು ಡ್ಯೂ ಟು ದ ವೇರಿಯಸ್ ಫ್ಯಾಕ್ಟರ್. ಬ್ಯಾಟ್ರಿ ಒಳಗಡೆ ಏನಾಗಿದೆ, ಮೇ ಬಿ ಎಲೆಕ್ಟ್ರೋಡ್ ಹಾಳಾಗಿರ್ಬೋದು, ಅಥವಾ ದೇರ್ ಮೇಡ್ ಬಿ ವೆರಿ ಮೆನಿ ರೀಸನ್ಸ್, ರೈಟ್? ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ ಸೆಲ್ಸಲ್ಲಿ ಬೇರೆ ಬೇರೆ ಥರ ಪ್ಯಾರಾಮೀಟರ್ಸ್ ನೋಡಬೇಕಾಗುತ್ತೆ ನಾವು, ಡಿಗ್ರೇಡೇಷನ್ ಯಾಕೆ ಆಯಿತು ಅನ್ನೋದು, ರೈಟ್? ಯಾಕೆ ಟೆಂಪ್ರೇಚರ್ ಜಾಸ್ತಿ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟು ದ ಸೆಲ್ಸ್ ಮೇ ಗೆಟ್ ಡ್ಯಾಮೇಜ್ಡ್ ಆಲ್ಸೋ ಸಮಟೈಮ್ಸ್, ರೈಟ್? ಅದು ಕೂಡ ರೀಸನ್ಸ್, ದಟ್ ಮೇ ಬಿ ವುಡ್ ಬಿ ದ ರೀಸನ್ಸ್. ಒಂದೇ ಸಲ ಸೆಲ್ಸ್ ಡಿಗ್ರೇಡ್ ಆಗಿದೆ ಅಂತ ಹೇಳೋಕ್ಕಾಗೋದಿಲ್ಲ. ದೇರ್ ಆರ್ ಮೆನಿ ಫ್ಯಾಕ್ಟರ್ಸ್. ಸೆಲ್ ಹಾಳಾಗಿದೆ ಅಂತ ಒಂದೇ ಸಲ ನಾವು ಹೇಳೋಕ್ಕಾಗೋದಿಲ್ಲ. ಸೊ ಡ್ಯೂ ಟು ದ ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಆಗಿರ್ಬೋದು, ಡ್ಯೂ ಟು ದ ಹೈ ಟೆಂಪ್ರೇಚರ್ ಓವರ್ ಚಾರ್ಜಿಂಗ್ ಕೂಡ ಆಗಿರ್ಬೋದು, ಟೆಂಪ್ರೇಚರ್ ರೈಸ್ ಆಗೋದು ಕೂಡ ಆಗಿರ್ಬೋದು. ಚಾರ್ಜಿಂಗೇ ಆಗ್ತಿಲ್ಲ ಅದು. 100% ತೋರಿಸ್ತಾ ಇದೆ, ಇಟ್ ಇಸ್ ಶೋಯಿಂಗ್ 100% ಆಫ್ ಚಾರ್ಜಿಂಗ್, ಬಟ್ ಇಟ್ ಈಸ್ ನಾಟ್ ಏಬಲ್ ಟು ಚಾರ್ಜ್ ಪ್ರಾಪರ್ಲಿ. ಸೊ ದಟ್ ಈಸ್ ದ ರೀಸನ್ಸ್. ದೇರ್ ಆರ್ ಮೆನಿ ರೀಸನ್ಸ್ ಫಾರ್ ದಿ ಡಿಗ್ರೇಡೇಷನ್ಸ್. ಅವಾಗ ವಾಟ್ ವಿಲ್ ಹ್ಯಾಪನ್, ಇವಾಗ 300 ಕಿಲೋಮೀಟರ್ಸ್ ಹೋಗಬೇಕಿತ್ತು ಆ್ಯಕ್ಚುಲಿ ಫಸ್ಟಿಗೆ ನಾವು ತೊಗೊಂಡಾಗ, ರೈಟ್? ಬ್ಯಾಟ್ರಿನ ಇವಾಗ ಏನಾಗ್ತಿದೆ, ಇಟ್ ಈಸ್ ರನ್ನಿಂಗ್ ಓನ್ಲಿ ಫಾರ್ 150 ಕಿಲೋಮೀಟರ್. ಬಿಕಾಸ್ ಆಫ್ ದಿ ಡಿಗ್ರೇಡೇಷನ್ಸ್, ಬಿಕಾಸ್ ಆಫ್ ದಿ ರಿಡಕ್ಷನ್ ಇನ್ ದಿ ಸ್ಟೋರೇಜ್. ಎನರ್ಜಿ ಸ್ಟೋರೇಜ್ ಯಾಕೆ ಸ್ಟೋರ್ ಮಾಡ್ತಾ ಇಲ್ಲ, ಎನರ್ಜಿ ಯಾಕೆ ಸ್ಟೋರ್ ಮಾಡ್ತಾ ಇಲ್ಲ ಅಂದರೆ ಡ್ಯೂ ಟು ದ ಕೆಮಿಕಲ್ ಫ್ಯಾಕ್ಟರ್ಸ್ ಆಗಿರ್ಬೋದು, ಡ್ಯೂ ಟು ದ ಫಿಸಿಕಲ್ ಫ್ಯಾಕ್ಟರ್ಸ್ ಇನ್ ದ ಬ್ಯಾಟ್ರೀಸ್ ಆಗಿರ್ಬೋದು. ಲೆಟಸ್ ಯಾವ್ಯಾವ ಥರ ಫ್ಯಾಕ್ಟರ್ಸ್ ಬರುತ್ತೆ ಅನ್ನೋದನ್ನು ನಾವು ಒನ್ ಬೈ ಒನ್ ಸ್ಟಡಿ ಮಾಡೋಣ, ಕೆಪಾಸಿಟಿ ಫೇಡ್ ಆ್ಯಂಡ್ ದ ಪವರ್ ಫೇಡಲ್ಲಿ. ಬಿಕಾಸ್ ದಿಸ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಯಾಕಂದರೆ ಡಿಗ್ರೇಡೇಷನ್ ಇಸ್ ಆಲ್ಸೋ ದ ಒನ್ ಕಾನ್ಸೆಪ್ಟ್, ರೈಟ್? ವಿ ಹ್ಯಾವ್ ದ ಸಿಲೆಬಸ್. ಇನ್ ದ ಸಿಲೆಬಸ್ ದೇ ಹ್ಯಾವ್ ಗಿವನ್ ವೆರಿ ಕ್ಲಿಯರ್ಲಿ that you have to study the degradations. So right, the degradation is very important, right? Degradation ನೀವು ಕಲಿಲೇಬೇಕಾಗುತ್ತೆ. ಯಾಕೆ ಥರ ಡಿಗ್ರೇಡೇಷನ್ಸ್ ಏನಕ್ಕೆ ಆಯ್ತು ಅನ್ನೋದು ಇದ್ರ ಮೇಲೆ based on this you can do lot of research also, right? So if you understand the degradations, then you can do, if you go in depth, no, you will learn many things. All right. So degradation agade we can make one the major big project also we can do it, right? We can study the various factors, the chemical factor again. We can study with the chemistry of the batteries also. You can study what is the reason behind the degradations. All right. ಯಾಕಾದ್ರೆ ಡಿಗ್ರೇಡ್, you can study the electrical factors also, right? Electrode ಯಾವ ಥರ ಏನು ಬಿಹೇವ್ ಯಾವ ಥರ ಮಾಡ್ತಿದೆ, and the discharge of your batteries ಯಾವ ಥರ, electrons ಏನು the various factors we can study for the degradation, right? We can do the research on that. We can make a paper on that, right? So this is the a very important concept you have to learn, right? So that is the reason the people not expecting to, if the age item, if the cells got age, no, so EV we are not expecting to have the batteries in the EVs, because we are expecting for 300 kilometers. We don't expect for only 150 kilometers, right? I don't want to go for that kinds of vehicles, right? After aging we have to replace it, right? I've given the life cycle for the battery only for 5 years. Obviously it will may come for 5 years, right? If you don't maintain properly, right? If you make overcharging, right? Obviously due to some overheating it may degrade your batteries also. Sometimes you plug your EV into the socket, right? Then you leave it for a very long time. So what will happen? It gets overcharged. The temperature may rise. Yes, after 100% also it is getting overcharged and temperature may rise. So due to the rise in the temperature, the degradation will also happens. Due to the chemical factor, due to the chemistry also, the degradation will also happens, right? Due to the electrode failure, the degradation may happens. There are many reasons why the degradations will comes into the picture, right? We have to maintain the battery life. So you have to charge properly, you have to discharge properly, or else we are not expecting those kinds of the aged cells in the EV, because it will not providing it is not providing the 300 kilometers. It is just providing only 150 kilometers, which is half of the earlier range. All right. So next we'll see the power fade, right? So the power fade will tell us about the decrease in the cell power. So due to the effect of aging. So it is not giving the actual power what we are expecting the earlier, right? It is not delivering the actual power. So that is the reason why, due to the aging. After once you age, no. So now we're in the age of around 25, 26, 27 like that. Approximately, say example, we'll take the example if you are in the age of 25, right? So you'll run for approximately for 10 seconds you can cover the 100 meters, correct? So if you maintain that the same speed, 10 seconds in 100 meters, right? If you can you do it in the after the age of 85? It is not possible. It is highly impossible. You cannot have that kind of the speed. In 10 seconds, you cannot cover the 100 meters at the age of 85. So that is the aging. That is the aging factors, right? That is the aging factor even for the cell also. As like the human beings are getting aged, right? So people ಯಾವ ಥರ ಏಜ್ ಆಗ್ತಿದೆ ನಮಗೆ ವಯಸ್ಸಾಗ್ತದೆ ಏನಾಗುತ್ತೆ ಎನರ್ಜಿ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ ಹೊರತು ಎನರ್ಜಿ ಜಾಸ್ತಿ ಬರೋದಿಲ್ಲ ಮನುಷ್ಯನಿಗೆ ಶಕ್ತಿ ಜಾಸ್ತಿ ಬರಲ್ಲ ಏಜ್ ಆಗ್ತಿದ್ದಂಗೆ ಸೊ ದಟ್ ಈಸ್ ದ ರೀಸನ್ ಸೆಲ್ಗೂ ಕೂಡ ಏನಾಗುತ್ತೆ ಪರ್ಫಾರ್ಮೆನ್ಸ್ ಮಾಡ್ತಾ 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 ಏನಾಗುತ್ತೆ ಅದೊಂದು ಏಜ್ ಆಗಿಬಿಡುತ್ತೆ ಒನ್ಸ್ ಇಟ್ ಇಸ್ ಗೆಟ್ ಏಜ್ ನೋ ಸೊ ಯು ಕ್ಯಾನಾಟ್ ಎಕ್ಸ್ಪೆಕ್ಟ್ ದ these kinds of actual power earlier what it was being delivered to the loops, right? So that is the reason there is a decrease in the cell power. There is a decrease in the maximum power. Actual maximum power it would have some rated, right? So that we cannot expect in the batteries, right? So due to the aging factors, right? So we have to see the aging factors due to the various reasons, right? It will also impact on the your EVs also. It will impact on the EVs such as the poor accelerations of the vehicles, all right? And also while climbing the vehicles it can now deliver the high current because of the voltage sag. So these are the various reasons, right? So once the power fading occurs, no, due to the aging factor, right, we are expecting to have the more power. Actually we are expecting to have the more power from the cells. Now due to the aging factor, right, the cells is not able to deliver the actual power. It is not able to, while climbing your vehicle. For example, you have a lithium batteries in your EV vehicles, okay? So that vehicle, when you're climbing in the upwards, right, it may be two-wheeler or four-wheelers. So you require the high torque to generate from the battery, right? The battery is to power, that much of power has to be delivered to generate that amount of torque, right? So that's why it is not giving the maximum power, and it will not try to gain the current also. That much of current it will not gain, right? That is there is a declarations, that is we can say there is a poor accelerations. There is a poor accelerations in the hill climbings also. So that is that would be the reasons. That is makes a lot of impact for the EVs also, right? Power fade is also, it makes a lot of impact due to the aging of the your batteries, right? So that was and it will not deliver the actual current what we are expecting, right? Due to the voltage sag. Voltage sag will also get reduced. You may see that the for the cell it may be of 3.5, right? So it may reduce to around 2.3 or 2.1 volts only once it get aged, right? So we are designed that cell for to give the around voltage of 3.5 volts. Now you can't expect that far, right? They expect we have to keep, we have to think we can expect only the around 2 volts from 3.5 to 2 volts you can expect, right? So if you have the lesser voltage, no, so there is a voltage sag. You can say there is a voltage sag. How can it can give the current if the voltage is reduced? It is not possible, right? So if you take the power equation, no, so if you take the power equation, so what will happen? The power, it is not able to, it will not deliver any power, right? So P is equal to V square by R, isn't it? So P is, if you take the P is equal to V square by R. So if higher the value of R, right? So what will happen? The power, if R is very high, the power will be very less. Yes or not? If the resistance will be very high, if you take the equation P is equal to V square by R, you can just note down P is equal to V square. If you take the P is equal to V square by R, then if R is increased, obviously it is resting the more power. The power will be very, very less. You cannot have the expectation of the high power. So once the power is reduced while climbing the vehicles, while climbing the vehicles, what will happen? It will not deliver the high current, because it is expecting, the motor is expecting to have the high torque. Yes or not? So if you take in the induction motor, right? If you take in the induction motor, torque is directly proportional to the current. Correct. The torque is also proportional to the your slip also. Torque is also proportional to the current also. If you take in a DC motor, right? If you take in the DC motor, torque is proportional to the current, armature current. If you take in the DC series motor, torque is proportional to the IC square, right? Always the torque is depend upon the current. So if you not delivering the high current, how can you expect the torque? So that is the reason, because of aging factor. Because of aging factor, the power is not able to deliver. That is the biggest thing that is we are facing because of the aging factor. So that we have to overcome this, right? We have to overcome this. The design, the implementations, you have to make a lot of research why it is going to have the degradation, right? So we have to overcome from this, right? So that is what the power fed will tells actually. Cell power, that is a decrease in the cell power. So due to the effect of aging, once it is get aged, no, it will not able to deliver the maximum power. That is, it is very clear. So if you are aged, no, as I given the example of running 10 second 100 meters at the age of 25, 10 second 100 meters at the age of 85, it is not possible. The second case is not possible. All right. So for 10 seconds, you cannot take 10 seconds. You may take 30 minutes. You may take 30 minutes to walk for 100 meters. So this is the reason. This is the reason we cannot expect the high current also, right? So if you tell it to climb for a hill, you cannot climb at the age of 85, right? You can climb the hill at the age of 25, but it is not possible to climb at the 85, right? Because you don't have that much of power in your body only. Similarly, the cell also don't have that much of power to deliver the maximum current, high current, while climbing your vehicles, right? The battery is not delivering that much of power to the motor only. For example, if you're using a DC motor or induction motor, if you take the DC motor, the current is directly proportional to the torque. So current is able to draw, motor is able to draw the more current, right? It has to generate the more torque. So current is coming from the batteries, right? First of all, the battery is not giving any current only because of the not delivering the maximum power. It is failed to deliver the maximum power because of the degradations, right? So we cannot have the expectation like that, right? So that is what they have given the very basic example to understand the power fed, right? The power fed will makes a lot of impact in the your poor accelerations, also hill climbing. It will not able to deliver the high current. So because of the voltage sag, the voltage will not, we can't expect that much of voltage in the aged cells, right? So these are the various causes, right? It will due to the the reasons are very specific, right? Sometimes the internal resistance from the electrolytes may decompose also. That would be the reasons also sometimes, right? So we cannot say the actual why the degradation is happening in this cell, why it is not delivering the power. The electrode, if you say have an electrode, for example, if you take electrode in the batteries, right? When you talk about the electrode, so what will happen in the electrode actually? The electrode internal resistance, the internal resistance of the electrode may be decomposed. It is not having to try to generate that much of energy, right? The due to the electrode cracking. See, I've given the example of one more. I'll take the one more example to make you understand very clearly, right? So when the age of 25, your bones are very strong. Correct? Your bones are very strong. If you come at the age of 85, no, the bones will be very, very weak. If you press your bone, no, it will be broken very easily. If you fall down, no, your bone will get broken up easily. So that is the reasons. Understand, no? So because of the electrode also, if you take in the electrode, what will happen in the electrode? Earlier, when you take for the first time, no, during time of manufacture, electrode is very strong. As the age comes on, as the age get increases, the day by day, the age because of the aging factor, what will happen? The electrode may get cracked. So electrode may get cracked. So due to that reason also, it is not able to deliver your current. It is not able to deliver the current which can generated by the torque. If it is not generating the torque, the hill climbing for the EV is not possible, right? So that's why you have to see the power fade also, right? So power fade is also a very important factor, right? Because of the aging. If during the time of aging, what will happen? As I given the example of to make you to understand very clearly, at the 25 age, you are doing a lot of highly energetic, right? Highly energetic, you have your bones are very strong. When you come at the age of 85, your bones may have a very less energy, right? In the bone, in the inside your bone, you have the bone marrow. That bone marrow will have a very less amount of energy. It will not generating more energy. It's also to stand up or to sit in the somewhere else, right? So because of the aging factor, right, the bones may have don't have much strong enough. So that is the reasons in the bone also, if you fall down, the bone will broken up, right? Sometimes if you fall from the bike, you may have the crack lines in your bone also. So this same, if you take the example in the cells also, in the electrodes, right, anode and cathode electrodes, due to the cracking in the electrodes, it is not able to give the much current. There is no recombinations of the electrons, not able to generate the current. So these are the various reasons why the aging, due to the aging factor, the electrodes may, due to the crack also, the degradation will happen. That's why the current it is not able to provide. That's why you cannot expect the more current in while the hill climb of the electric vehicle, right? That determines how much of power can the battery deliver without lowering the speeds. So this is the reasons. So all right. So next we'll see the lithium ion batteries of charging and discharging, right? So we'll see the lithium ion batteries. That is what we have to discuss about the lithium ion batteries as per our syllabus of contents, right? So we have the lithium ion batteries. In the last sessions, we have discussed about the parameters, right? Charging, discharging, talked about the C rate and the capacity, that is ampere hour, why it is called as ampere hour. But we have discussed in earlier sessions, and in the earlier, this session we have discussed about the degradations also. We'll see about the lithium and the lead acid batteries and also the solid batteries also. All right. So the question may be asked based on your the battery technologies, how the batteries has been various technology has been used to in the for the giving the more life for the batteries, right? What are the different technologies they are going to use? The other technology been used for the development of the batteries. So all right. So let us see the battery lithium ion batteries, the charging and discharging. Uh, I hope it is clear to everyone. Is it clear, Uday, Sneha, Shivraj?
Yes, yes.
Yes,
Yes,
sir.
sir.
Okay, all right, we'll go to the other factor, other topic, that is the lithium and batteries in the charging and discharging, right? All right. Let I'll give the little more of concept to you to understand very clear about the degradation. Then later on we'll go to the lithium ions. I'll try to share the slides once again. All right. So actually, if you take the lithium, if you take the example of the lithium and batteries, no, you can see there are we have the two collectors, that is anode and cathode, right? So where these electrons, if you say the lithium ions will be exactly in in between the two electrodes, right? So just 1 minute. So let us see. Am I audible?
Yes, sir.
Yeah. So let us take the example of the lithium-ion batteries for charging and discharging, right? So you can see there are we have the two plates, right? One with the cathode, other with the anode, right? So the cathode may have the lithium components, right? And also the anode may have the copper file graphites. So let us see how in between these two we are going to have the liquid electrolytes, that is lithium ions. This is what the liquid electrolytes, right? So which is placed over here, isn't it? In between these two electrodes, they are going to place here, right? So during the charging and discharging, right, how the electrons will try to move in a direction, bidirections, right, during charging and discharging of the batteries, right? So let us see how the degradations will happen with respect to this, right? With respect to this, the chemical reaction, the chemical equation may also relates with this for the recombinations of the electrons with the lithium ions, right, to form the lithium phosphates, right, lithium phosphates. So let us see how these recombinations will happen also, and what is the behind the degradation, right, in the, especially with the lithium ion batteries, right? So with respect to this, we are going to study the various things, right? All right. Now you can see this is images will tells you very clearly, right? There are many things over here, right? The electrolytes, we have dead lithiums. All right. So here I've given the example of there is a lithium over here, right? There is a, you can see the orange, this is golden color. The lithium ions are over here, isn't it? And also this color, red color, it tells about the electrons which is moving, right? And this in these directions. And black color will indicate the transition metal from oxide metals, right? Nothing but the graphite metals. These are the graphite metals. You can see this is the liquid electrolytes, right? That is the lithium ions is the liquid electrolytes. And also with electrodes, how the electrode will also have the cracks, and also how the electrons will will not try to give the current, and also what is the reason behind for the degradation, right? So this image will gives a very clear picture, right? So the lithium ions are dead completely. These ions, what you're expecting over here, no, the lithium ions, what we liquid electrolytes, what we have been placed inside between the two electrodes, the liquid electrolytes. So these are under the failure, right? These are under the dead conditions. All right. So these lithium ions are not able to perform its action properly, right? Because of the dead lithiums. And also you can see there is a secondary CA formation, right? You can see there is a fire sensation. You can see. All right, you can see there's a lithium depositions where on the other layers. So this may the very reason, that is the secondary electrolytes interfacing formations may occur. You can see the secondary solid electrolytes interface may also happen over on this surface also on the graphite. The graphite nothing but over here, this side. Right. This side, what you can see, sorry, this side is a graphite. All right, this side is a graphite. So this side graphite where there is a reasons to have the other secondary solid electrolytes interfacing also takes place. So due to that, the degradation may also happens. Right. This is the secondary solid electrolytes interfacing, and this is the primary SI formations. Right. So these are the secondary formations, and so due to the dead lithium ions also, we are not able to have the proper charging and discharging. So these may be the reasons for the discharging. Sometimes the electrodes may also have the cracks. So if this electrode may get cracked during the charging and discharging, so that also may the reasons not to charge the battery properly for the 100%, right? What we are expecting for the 100%, right? So there are various reasons. And also if you see this graphite, right? This is actually the graphite where you can see that there is a problem with the graphite also. So that is the secondary formations of solid state electrolytes interfacing of this graphite also may occur. Due to this, there is a might be the failure of failure of the to produce it to deliver the current, or to deliver the voltage what we expect for the battery from the batteries. So those are not possible. So these are actually mechanisms which is happening for the degradation, right? So degradations, I told there is many things to happen. It is a gradual processes by which a battery ability to store and deliver the energy decreases, right? So due to the natural process, what is happening? It is not able to have the much storage and it is not able to deliver the energy. So that this would be the reasons also, right? So this is the reasons also, and we can see there is a lifetime depends on the operations and how fast it will degrade, right? It also depends on the lifetime. Lifetime of the batteries also depends, right? If it life is very less, right? If you take the example of your the human being, right? So nowadays life you cannot expect a much life more than the 60 years, correct? 60, 70 years. We cannot have that life. What the people, our ancestors had the life for because of good health and because of the good nutrients, foods, and also because of very hygienic food they were having in the earlier days. And they used to have very active, right? But nowadays we don't have that kind of activeness because of we are not, we can accept ourselves that we don't have that much of energy. So what ancestors they had, because of we nowadays many people are getting lot of sugar, BP, asthma, diabetes, many things are they are getting. So this makes the human beings to get the degraded very soon and to reduce their life. So this is one of the best example to understand, right? So these are, you can say, these electrolytes are your dead lithiums are secondary formations of solid state electrolytes, primary formations of the solid state electrolytes, and lithium depositions of the other layers, right? These are the various reasons why the battery is going to be degrades, right? As I told, these are the example like your BP, sugar, asthma, diabetes, right? To reduce your life. Understood? So let us see the types of degradations, right? Degradations, I have talked about the secondary, that solid state interfacing degradations. We have mechanical degradations, right? We have electrochemical degradation, we have thermal degradations, and cycle and calendar life of the degradation, right? So what are the various factors that may have the affecting the degradation, right? The most common factors leads to the degradation is one is the temperature. That is what I talked about in the previous sessions, right? I talked about in the previous session. Temperature will makes a lot of impact, right? For example, if you fall sick, right? If your temperature is around 100 degree, then it will go to 120 degree, then it will go to 140 degree, then it will go to the 200 degree. So what will happen to your body, right? So we should have to, we are adapted to the particular temperature in your body, isn't it? You cannot have that much of temperature in your body. Correct. So the temperature is also the major factor. If the temperature rises in your body, no, so you'll fall sick, you will fall ill. So that is the reason that will go to the extreme conditions of your health, right? The temperature is a major factor. So we have to think about the temperature, right? So temperature is also the major factor while charging and discharging of the batteries. So that may also lead to the degradations. All right. So that may also lead to the degradations of the batteries due to the chemical reactions and internal resistance, right? As I told, I was talking about the internal resistance also, right? If the resistance is going to be increased, right, what will happen to the power? P is equal to V square by R, right? Power will be very less. If R increases, internal resistance increases, the power will be very less, right? If the temperature extremes, accelerate the battery degradation by increasing the chemical reaction, right? If the chemical reactions also keep on increases, right, the life of the batteries will also be reduced because of rise in the temperature. So when you charge the batteries, now what will happen during the time of state of charge, right? The temperature will also may go to extreme level. If you overcharge, what will happen? The temperature will also rise. Yes or not? So the same thing, because this is one of the factor for the degradation. The temperature is one of the factors, right? You cannot have the overcharge. If you charge your battery for very longer times, right? So without turning off the plug, without unplugging your battery from the supply, right? So what will happen? It gets overcharged. So during time also the battery may have the degrade its life also, right? Because of rise in the temperature, right? So temperature extremes accelerate the battery's degradation, right? Temperature is a major factor, right? So in the earlier session, I was discussing about the temperature, right? So let us see the temperature. I want to maintain the same temperature. We maintain the same temperature. What will happen? For example, if you maintain the temperature of your body, right? So you don't, right? If your temperature is increased for 80 degree, 90 degree, 120 degree, right? We can we can tell that you are not very healthy, right? You may have the sick, you may have fever. So let it we make the predictions. All right. So with respect to that only, we have to maintain the temperature. If you maintain the temperature in your body, what will happen? you will become you will be very healthy also, right? You can take that how much of amount of food is required as regular routine. As a regular routine, you can have it your food. Yes or not? If you have the excess of temperature in body, no, you cannot have the taste of food, right? You don't have to you don't have to have that kind of the taste of the food. You cannot expect only because there is a rise in the temperature. So that is the reasons. So if you rise in the temperature, no, to the extreme level, so that will accelerate the battery degradations, right? ಸೊ ವಾಟ್ ವಿಲ್ ಡೂ ಏನು ಮಾಡುತ್ತದೋ ಬ್ಯಾಟ್ರಿನ ಬೇಗ ಹಾಳು ಮಾಡೋಕ್ಕೆ ರೆಡಿ ಮಾಡುತ್ತೆ, ರೈಟ್? ಸೊ ದ ಬ್ಯಾಟ್ರಿ ವಿಲ್ ಟ್ರೈ ಟು ಸ್ಪಾಯ್ಲ್ ಇಮಿಡಿಯೇಟ್ಲಿ, ರೈಟ್? ಇಫ್ ಯು ರೈಸ್ ದ ಟೆಂಪ್ರೇಚರ್. ನಿಮ್ಮ ಬಾಡಿಲಿ ಯಾವ ಥರ ಟೆಂಪ್ರೇಚರ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, ಏನಾಗುತ್ತೆ ಅವಾಗ ಬಾಡಿಲಿ ಟೆಂಪ್ರೇಚರ್ ಜಾಸ್ತಿ ಆದಾಗ ಊಟ ಮಾಡೋಕ್ಕಾಗೋದಿಲ್ಲ, ರೈಟ್? ಬಿಕಾಸ್ ಬಾಡಿ ಇಸ್ ಕಂಪ್ಲೀಟ್ಲಿ ಅಂಡರ್ ದ ವೆರಿ ಹೀಟ್. Yes, and body is under the high temperature. You cannot feel something, you don't feel the taste only. Earlier taste ನಿಮ್ಗೆ ಏನು ಅನಿಸ್ತಾ ಇರ್ತದೆ ಅನ್ಸೋದಿಲ್ಲ, ಏನು ತಿಂದರೂ ಕೂಡ you don't feel the taste only. So all right, so if the temperature rise, if you go for overheating of the batteries, no, temperature will rise, right? So that will also accelerate, that will help to make the battery very fast degradations, right? By increasing the, because of increasing in the chemical reactions in the batteries only, right? Due to the chemical reactions in the ಕೂಡ ಆಗೋ chances ಇರುತ್ತೆ, and also the internal resistance of the battery. All batteries will have the internal resistance, right? If you take the EMF of any batteries will have the internal resistance, right? So that resistance also we have to maintain. So there is a maintain the resistance and also maintain the chemical reaction properly, and you have to maintain the temperature, right? If you don't maintain the temperature, what will happen? The chemical reaction, because of increasing the chemical reaction, the temperature will also rises. Yes, sir. If the what it's just like we can understand very in a simpler way, right? If you eat something, right? If you eat hygienic food, what will happen? Your body under the healthy conditions, it will maintain your temperature of your body, correct? If you don't eat the things which is not suitable for your body, right? So what will happen inside your body? The metabolism actions, right? The metabolism actions, what will it will make a certain different kind of metabolism action. What actually it has to supposed to do, it will not do that one. It will do some other reactions in your body, right? So what will happen? Because of that, you may fall sick, you may have the fever, you may have start having the different kinds of sensations feeling in your bodies. So because of the chemical reaction only, the temperature will rise. So this is the one major factor, right? So I'll show you the various data which has been taken from the battery cells. All right. So this is the data. Is it visible? Is it visible now to everyone?
Yes, sir. Data sheets.
Uday, Sudas,
Yes,
it
sir.
is visible.
Data sheets is available.
Yeah, yeah. So this is the data sheet we have taken for doing the research. All right. So let us see. We have taken the plenty of data. Just observe. We have taken the voltage, current, and temperature also. Right. I have taken more than 2,000 data. All data during the I made the prediction of the batteries. Every time I used to make the prediction. So this data we have given for the machine learning. The machine is able to justify the battery conditions every second, every millisecond it will justify, because I want to increase the life of the batteries, because I don't want to go for the degradation, right? So let us see how this battery is going to be. We have taken the various data to make for making the analysis, right? See, there is a time, and we have the current, we have the voltage, we have the temperature, right? So these are the various parameters. All right. So I'll mark it in the red. Okay, right. So these are the various parameters. You can see the current is around 2.1 pi, right? The voltage is around 2.5 also. The temperature is almost 26 degrees. All right, because this is the temperature I have to maintain during charging and during discharging, right? The current is also been gradually it is increasing, right? And voltage also gradually is increasing. So during the time you have to maintain the constant temperature. If you don't maintain the temperature, no, so it will go for the your concept. Then you have to go back to your concept, right? The temperature, right? So this is the actual the temperature where it will accelerate the battery degradation by increasing the chemical reaction and the internal resistance of the batteries. So that's why you have to maintain the constant temperature. All right. If you see the current also, if you see the voltage also, temperature is almost same. All right. So here we have taken
ಸರ್ ಯಾವ ಫಾರ್ಮುಲಾದ ಮೇಲೆ ಇದು ವರ್ಕ್ ಆಗುತ್ತೆ ಸರ್ ಅದು?
this one, no?
ಸರ್
So we
ಅದು
have.
ಟೆಂಪರೇಚರ್ ವ್ಯಾಲ್ಯೂಸ್.
So this will I'll teach you in the upcoming topics, right? So this you will understand when we go for the state of charge. Right, we have the state of charge. Ali nimge equations alle helkodtini yav tara work agutte ನಾನು. Here you have, is it visible, no? State of charge.
Yes, sir.
Yes, sir. In this, no, in the state of charge, I will explain it very clearly. Because ಅಲ್ಲಿ ಗೊತ್ತಾಗುತ್ತೆ ನಿಮಗೆ ಡೇಟಾನ ಆರ್ಕಿಟೆಕ್ಚರಲ್ಲಿ ಆ್ಯಂಡ್ ಸ್ಟೇಟ್ ಆಫ್ ಚಾರ್ಜಲ್ಲಿ ಸ್ಟೇಟ್ ಆಫ್ ಹೆಲ್ತಲ್ಲಿ ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ ಎಸ್ಟಿಮೇಷನ್ ಹೆಂಗೆ ಮಾಡೋದು ಅಂತ, ರೈಟ್. ಎಸ್ಟಿಮೇಷನ್ ಯಾವ ಥರ ಮಾಡಬೇಕು, ಟೆಂಪ್ರೇಚರ್ನ ಯಾವ ಥರ ಮೇಂಟೈನ್ ಮಾಡಬೇಕು ಅನ್ನೋದು ಅಲ್ಲಿ ಗೊತ್ತಾಗುತ್ತೆ ನಮಗೆ, ರೈಟ್. ಸೊ ದಿಸ್ ಈಸ್ ಎಕ್ಸಾಂಪಲ್ ಟು ಮೇಕ್ ಇಟ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಬಂದರೆ ಟೆಂಪ್ರೇಚರ್ ಬಂದಾಗ ಮಾತ್ರ ನಾನು ನಿಮಗೆ ಇದು ಡೇಟಾ ಶೀಟ್ನ ತೋರಿಸ್ತಾ ಇರೋದು. ಯಾಕಂದರೆ ಟೆಂಪ್ರೇಚರ್ ನಾವು ಎಲ್ಲ ಕಡೆನೂ ಮೇಂಟೈನ್ ಮಾಡ್ತಾ ಇದೀವಿ. ದೇರ್ ಇಸ್ ಎ ಫಾರ್ಮುಲಾ ಫಾರ್ ಸ್ಟೇಟ್ ಆಫ್ ಚಾರ್ಜ್, ರೈಟ್. ಇಟ್ ಈಸ್ ಡಿಪೆಂಡ್ಸ್ ಅಪಾನ್ ದಿ ಕ್ಯೂ ಫ್ಯಾಕ್ಟರ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ನಥಿಂಗ್ ಬಟ್ ದಿ ಕೂಲಮ್ ಚಾರ್ಜಸ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರ್ತದೆ. ಓಕೆ, ಎಷ್ಟು ಪರ್ಸೆಂಟ್ ಆಫ್ ಕೂಲಮ್ ಆಫ್ ಚಾರ್ಜಸ್ ಉಳ್ಕೊಂಡಿದೆ ಟು ದ ಆಕ್ಚುಯಲ್ ವ್ಯಾಲ್ಯೂಸ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಇಫ್ ಇಟ್ ಈಸ್ 60/100 into 100, what is the percentage of state of charge? It is 60%. So that is a formula we are just maintaining, right, for the state of charge, isn't it? So ಅದು ಫಾರ್ಮುಲಾಸ್ ಎಲ್ಲ ನಿಮಗೆ ಸ್ಟೇಟ್ ಆಫ್ ಚಾರ್ಜ್ ಮತ್ತು ಸ್ಟೇಟ್ ಆಫ್ ಹೆಲ್ತಲ್ಲಿ ಕರೆಕ್ಟಾಗಿ ಹೇಳ್ಕೊಡ್ತೀನಿ. ಫಾರ್ ವೆನ್ ಟೆಂಪ್ರೇಚರ್ ಬಂದಾಗ ನೋಡಿ ಎಷ್ಟು ವಿ ಹ್ಯಾವ್ ಟೇಕನ್ 2000 ಡೇಟಾಸ್. ಫಾರ್ ದಟ್ ಓನ್ಲಿ ರೀಸನ್ಸ್ ಐ ಆಮ್ ಜಸ್ಟ್ ಶೋಯಿಂಗ್ ದ ವಿ ಆರ್ ಮೇಂಟೈನಿಂಗ್ ದ ಟೆಂಪ್ರೇಚರ್ ಆಸ್ ಎ ಕಾನ್ಸ್ಟೆಂಟ್. ವಿ ಆರ್ ನಾಟ್ ವೇರಿಂಗ್ ದ ಟೆಂಪ್ರೇಚರ್, ರೈಟ್. ಕರೆಂಟ್ ಸ್ವಲ್ಪ ವೇರಿ ಆದರೂ ಕೂಡ ಟೆಂಪ್ರೇಚರ್ ಏನಾಗ್ತಿದೆ, ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಹ್ಯಾವ್ ದ ಸೇಮ್ ವ್ಯಾಲ್ಯೂಸ್. ಆಲ್ ರೈಟ್. So this is almost we have taken the data more than 2000, right, and from the data sets of the batteries. All right. Right, you can see the temperature. Already the temperature is almost 26 to 25, 26 to 25, 26 to 25. If we see for n number of times, the time is also getting increased, right. On the first serial number we have the time, second we have the current, and third we have the voltage, and fourth we have the temperature, right. You can see all the datas, right. Sometimes there is a reversible current also, right. It is because of the charging and discharging condition that we are just maintaining the temperature. Almost you can see there is a temperature is not going beyond the 28, 29, 30 only, right. We have to maintain the temperature. The cell temperature we are just maintain for 25 to 26 degrees centigrade, right. If you increase the temperature, obviously the chemical, due to the chemical reaction, the internal resistance, the battery life will also get degraded. All right. So this is the reason, right. I have taken the plenty of data to make you to understand. I have taken the more than almost so much of data have been collected. So this data has been tested. This data has been tested at what time, where the specific time, and the specific time what is the temperature is going to rise. Almost if you see from the first to here, right, from the first here, the temperature is almost 25 degrees, and the voltage has been increased gradually from 3 to 4 volts, right. So this is the reason how we have to maintain the temperature, right. So if you take the n number of data also, please try to have them maintain the temperature is very important in the batteries, right. If you don't maintain the temperature, no, obviously the battery life will go very easy way, right. So this is the data sets. It gives a very clear picture for you, right. It gives a very clear picture. So I just given these data to for the machine learning. The machine has been trained to the machine, right. The machine is able to judge every second it used to judge the battery life, the battery conditions of the temperature, what is happening in the battery condition during the state of charge, during the state of health. It is monitoring the health conditions also, right. So that is what the battery is giving these kinds of data for me for every milliseconds. All right. So that's why we have to look after this about the temperature also, right. Temperature is the major factor, right. It is an extreme factor for all the your batteries, right. You have to look after the temperature. See, not to be accelerate, not to start the degradation because of the temperature, because of rising in the chemical reaction, because of having the internal resistance, decreasing in the internal resistance, right. So these are the various reasons we have to think about the temperature also, right. So next, when you come to the point of charge and discharge cycle, right. So charge and discharge cycle I have explained in the last class. For the 5000 or for the 2000, that is the life cycle of the battery. So it will charge for the repeatedly, it will charge for 2000 times, repeatedly it will discharge for the 2000 times. After that the life is gone, right. That is what I have explained very earlier. You can see in this, right. So number of full charge and number of discharge cycle, number of full charge and discharge cycle. So that will ends the life of the batteries, right. So in the last sessions I have given the data of your self discharge, the life cycle, right. Everything I have given in the last. You might have taken the screenshot also. It is very easy to understand the life cycle, right. Number of full charge, right, and also discharge that predicts the life cycle of the batteries. For example, if you have taken a battery for 3.5 volts, right. So the life cycle may be of around 2000. So once it is charged and discharged for 2000 times, no, then life is gone. You have to throw the cells. So life will become like this, right. That is the end of the life, right. You cannot expect the battery for the next, right. So then you have to go for the degradation. So you have to remove the batteries, right. then you have to decay the batteries inside the earth if it is a lithium water it may be. All right. So that's why this degradations will happen. This is one of the major factor, right? So temperature and the charge and discharge cycle, right? So if the charge cycle is around 2000, it has to give for 2000 for next 5 years. Then the life is gone. All right. Then we can expect the life is gone. Within a span of 2 years or 1 year, right? You cannot expect to complete the 2000 cycle. So that is a major wrong thing that we are going to understand. Correct. So when prediction is around 2000 for 4 years, then the battery is having a good life. All right. If the same batteries is not able to give 2000 cycles in a span of 4 years, it is giving only for 2 years, then the battery has some problem with that. Means it may have discharging, it may have problem with your electrodes, it may have problem with the chemical reaction, it may have problem with the charging the your battery energy, it may have problem with the temperature, it may have problem with the chemical reaction, it may have problem with the internal resistance. So there are many reasons, right, which can degrade the life of the batteries also. That causes the degradations immediately, right? So life cycle is also very important. Understand now? So life cycle also depends upon the charging and discharging. It is very simple. You can understand in a very simpler way, right? So if you eat it properly in a healthy way, right? See, if you take, if you're in the age of around 25, 26, all right. So if you eat properly, if you keep the proper diet in your food, right? So you'll be very healthy. If you eat as much as more enough, if you eat, what will happen? So usually that doesn't make more digestion in our bodies. All right. So usually if we keep on eating, what will happen? You'll grow more fat, you will become more fatter and fatter and fatter, isn't it? So many things, many diseases will start coming over there. Yes or not? Then your life will get degraded if you don't maintain your physique also. Similarly, that is called the life cycle. That is called our life cycle of the human beings. Correct? Eat properly and do proper exercise and have healthy food, and you have to maintain your all kinds of metabolism activities in taking your food, whatever it may be. All right. So everything should be in the proper ratios. Should be in the proper ratio. Then only your life will be very good, so that you don't have any kind of the diseases. All right. So if you keep on eating every day, morning also you're eating, and afternoon also you're eating, you're going to have more snacks also. Every time you keep on 24, what do you say? Among 24 hours you're eating, 12 hours only you're taking the food only. So what will happen to your body? Correct. If you eat whichever form, no, if you keep on eating, what will happen to your body? And you are not doing any kind of exercise also. Correct. Obviously, in your body, no, this what is the fat, the cholesterol will start increasing in your body, right? So thereby BP will also start increases. All right. So thereby you may have different kinds of diseases, asthma, everything. It will keep on. It will attack. It will attack immediately for. Correct. So that will degrade your life. So that is how charging life cycle will decreases. Means if we want to survive for another 40 years, no, we should do all these kinds of activities. If you don't make the proper ratios of your body food contents and exercise, so that your life will get reduced. Correct. So because you have to maintain it, right? Similarly, we have to maintain the life cycle of the battery, right? That is what it has to be. Again, the time period for 2000 cycles, right? 2000 cycles, if you give for 2000 cycles, means it should come for 4 years only. You cannot expect for only 2 years, right? Within a span of 2 years, it is means there is a damaging, there is something has happened in the batteries, right? So we cannot identify because we are not battery engineers, right? We are just looking think what is being happened in the batteries. We are just going to learn the things what is happening in the batteries, right? So that is what we have to think, focus more on the life cycles. Why life cycle is reduced? Why life cycle? If the person is survived for 80 years, then it is fine. If the person is not survived for 80 years, then that person may have certain kind of diseases, isn't it? We have to agree for this, correct? So same thing, the charging and discharging of the cycle, right? The repeated charge and discharge cycles causes the battery degradation, right? So if we keep on overcharging, if we keep on discharging, if the discharging and charging is not happening properly, frequently, then the life cycle will also may get degraded, right? So if it is giving for a 2000 cycle for a span of 4 years, then it has to give that as per the manufacturer, right? It has to give that cycles. It is not giving that much of cycles, no, but it is coming only for 2 years. Okay, you are told for 2000 cycles, it is giving only for the 2 years. Then there is a problem with your batteries, right? Because of your damaging internal components in the battery. Electrode maybe have been cracked. right? Just like you're cracking your bone at the age of 85, right? Age cells. I'm just talking about the age people, right? So like that, if you keep on having the breakage in your body, no, it will leads to the damage. Similarly, there is a breakage in the cells. If you, there is a breakage in the electrodes, if there is a crack in the electrodes, so that may also reduce the life of the batteries, correct? So that would be the reasons also. There are many reasons for the reducing the life, right? The internal resistance, cracking of the electrodes, right? So these are various reasons for the degradations of the your battery conditions. All right. I hope it is very clear to you. And also, if we talk about the various types of charging methods, right? The state of charge, the state of L, the depth of discharge, right? When you talk about the depth of discharge, it tells about the accelerate the battery degradation by causing the electrodes wear and internal resistance, right? So there is a chances of having the wear and tear in the batteries also, right? Sometimes. So that would be the reasons for the degradation, the depth of discharge also, right? So depth of discharge will tells about accelerate the battery degradation. It is becoming more and more faster, right? It will try to reducing its lifespan as much as possible, right? So shallow discharging prolongs reduces the battery life also. All right, there are various factors where the depth of discharge, right? If it is charging for 100%, right? If it is fully charged, then the depth of discharge may be around 20%, right? So that is a percentage of battery's capacity that should be used in a one cycles. Correct. That should be used in a one cycle for 100% of depth of discharge. So that is what that is, which is equivalent to the fully discharge. So once you charge, no, you have to discharge properly. Alright, if the 50% is charged, 100% is charged, for example, if you charge for 90%, then you use for the 50%, again you are going to charge because the only batteries are under 50%, right? Again you are going to charge. So what will happen? It is not undergone the depth of discharge only. It is not completely discharge 100%. No, it is not. Your battery is not coming to the 100% of depth discharge only. So meanwhile, what you are going to again charge, right? You are going to again charge. So the concept of depth of discharge will not comes into the picture only, right? So that is a percentage of battery capacity which is used in one cycles, that we call it as a depth of discharge, right? The percentage of batteries, that is the percentage of battery capacities that need to be used, in one cycles. All right. So that is what if it is fully charged, then you should go for the fully discharged, right? If the 20% of depth of discharge will leads to the shallow discharging, and it will makes a prolong of the battery life also. So that is the reasons, right? So once you charge, no, you have to discharge properly. You cannot have the 20% of depth of discharge. It will tells the shallow discharge. If there is a 20% of discharge, no, the 20% of depth of discharge, it will tells the shallow discharge and will prolong the battery life also. It will try to prolong the battery life. So that is the reason. The frequent deep discharging stresses the battery electrodes, leading to the premature degradations. Correct. So if you charge for 100%, then discharge for almost when it is coming to 5-2% like that, right? Then it will have the proper battery life, right? So what we are doing? So see, we are not we are charging for 100%. Okay, we are charging for 100%. If the batteries come for only for the 50%, again also we are going for charge. Because we are traveling, for example, you are traveling for somewhere, no, we want 100% of charge, right? We feel that we cannot get the supply if we go and we stuck in between. All right. So that is the reason we are expecting to have the more charge. So that is the only reason we have to understand in the battery conditions, right? Everyone has to understand the battery conditions, right? The depth of discharge. If we charge for 100%, try to discharge for 100% only. At least if it is 20% of discharge, no, that will give the shallow discharge. It will give the prolonged battery life also. At least after 10%, 50% it comes, no, please go for charging. All right. If it is 70% of charging, no, if the 70% is charged in your batteries, right, 100% it is coming for 70%. Then what your people are doing? Again, will go for remaining 30% is there. Will compensate 100%. So that will leads to the prolong of your battery life also. It will not give the prolong of your battery life. It will obviously it will try to make that degradation. That is a prematurity of the degradation. Somewhere the electrodes may have kind of the various variable stress on the electrodes, right? So electrode will have a lot of stress, right? So it is very simple. You can understand the concept in a very simpler way, right? So if I give the more work to you, right? If I given already the one or two work, again if I give back to back again work, right, what will happen? You have to discharge the work first. First you have to discharge my work, isn't it? Then I'll give some other work. Then it will become very comfortable for you, correct? So if I give, already I've given the work, right? So again and again I'm giving the work for you. So what will happen? It will stress on your brain. You'll think that they have given certain stress, right? You cannot work properly. If I give frequently, if I give the work again and again, so you have to complete your work and kindly discharge, correct? Completely discharge it. Again, you take one more assignment, correct? Again, you discharge it. Again, you take one more assignment, then discharge it. Again, you take the new assignment, then discharge it. So that will give a prolonged battery life. All right. So that is what. If you say that the work is little bit is there, sir, only 10% is remaining, then it is fine. Okay, then you can discharge completely. You cannot have the work, 80% work is pending already. All right, again if I give the work, what will happen? Again 80% will get added up, correct? Again more stress will be there on your brain. So same thing when you talk about the batteries, no? So please look after whether it is discharged properly or not. Depth of discharge means it has to discharge completely, right? You have to see the battery life, because we are focusing more on the battery life. We are talking about the degradation factors, right? We have to focus more on the battery life. Battery life is very, very important. We actually, when we don't learn about this EV batteries, no, so many things will happen. That is a short circuit condition. In many side, if you see the many side, electric vehicle has got bursted. Electric vehicle has battery has got bursted, short circuited. It catch the fires. These are the various reasons, because they are not maintaining the battery properly. We should not blame on the EV companies, right? We cannot blame on the this kinds of the accident which is happening over there, right? So we are not maintaining the battery properly. That is our mistake, right? That is because of we are not discharging properly and we are not charging properly. Correct. Even the instruction is given by the manufacturer, right? They'll tell to make the completely depth of discharge and charge fully, make the fully charge. Don't go in between. 70% you charge, right? And you are thinking that, oh, 30% is remaining, I have to charge again. You feel that you have to charge again, right? I'll compensate for 100%. So what is it? Does it make any sense? You are putting more stress on the electrodes. You are putting more stress on the electrode. That is the example I've given to understand very clearly, right? If I give the work for, if I give the work, you have completed around 70% of the work, right? 30% is completed. Think 30% is already completed. 70% is remaining. Okay. Again, if I give the remaining 30%, so it will become 100% of work, no, for you. So it will be stressed on your brain only, right? You have to discharge first, given 100% of work. 70% is remaining. 30% you already discharged for me, right? Again, 70% is remaining. No, you please try to discharge remaining 70%. Then I will give the one more work to you, so that the stress will not happen on your body. Similarly, in the batteries also, batteries will also follow same thing, right? Batteries will also follow the same thing. You have to go for the depth of discharge. Understood? So this is the reasons. So this is the reasons where the depth of discharge will comes into the picture, and it leads to the degradations of the batteries. Correct? I hope it is very clear to you. So is it clear? Your voice is not audible, pa. Sneha, Sanjit,
Ah, sir.
is it okay? Is it clear? Concept is clear?
Yes, sir.
Degradations of the batteries. Okay, Uday, is it clear for you?
Yes, sir. Clear, sir.
Okay, so please try to focus on the degradations. Oh, you can do the research also in this. There are many research it is happening, because when EV has a lot of demand, electrical engineers have a lot of demand for in the EV industries, right? Because of batteries only, we have to improve the battery life. So that is very, very important. If we improve the battery life, no, so everybody will go for the EVs only. We'll make a zero emissions. We'll make the completely the green energy. We'll make the green energy. We'll use the renewable energy. We'll use our batteries. Everybody will start using our batteries. Everybody will try to use our electric vehicles in the roads. Right, in the upcoming 2030 or 2040, everyone has to use the electric vehicle batteries. Everyone has to use electric vehicle, because of we are making the research. We are learning the subjects to do something, to make some innovations. Right, after learning the subjects, we are going to do some projects on this. Right, we are trying to improve the degradations of the batteries, to overcome that. What are the various reasons, how to improve the battery life, right? And what are the problems that persisting in the batteries? We'll make the certain analysis on the batteries also, so that you'll understand the battery rate if once you do the P-will on this. All right. So this is the one reasons, right? So Other is the other thing is the charging methods, right? There are the various charging methods where we can go for the fully charged acceleration degradation by generating the excess of heat, right? During the charging method, what will happen actually? How it will affect, right? How will affect, as I told about the shallow discharge, right? Shallow discharge also I explained very clearly that the 20 to 50% of depth of discharge, right, prolong the battery life. So less stress on the electrodes, correct? That is shallow discharge will makes a prolonged battery life. At least you come back to 50, less than 50%, 40%, 30%, 20%. Then go for charging point. Don't go immediately when it is on a 70, 80%. Usually everyone we do. We plug our mobile charger to the mobile, no, our cell phones. If it is 80%, again will charge. So that's why everybody will tell in the market. So phone is not giving life, phone is not giving battery backup, phone is not giving battery backup. We are not understanding the concept of batteries only. So that is the reason people are not understanding the batteries, where the it is hitting properly, where it is the actual things which is hitting on the batteries, right? It is affecting on the electrodes. We are not thinking about the electrodes. In the mobile also they are using the lithium batteries. In the your laptop also they are using the lithium batteries. Why the laptop is not giving them that much of backup when it is giving for 3 hours? Once it is come on, you keep on charging. If you keep on charging, if you keep for plug into your laptop for the 24 hours or 12 hours or 8 hours, how it will give the life? You tell me. So you're putting more stress on the batteries. You are not supposed to do that. So all right. So that is the reason. Please understand the concept of depth of discharge. Depth means a very inner. Come to the lower values. Come to the lower values. All right. So depth of discharge means come to at least minimum for 20%. Please go for 20%, below 50%, 30%, 20%, or 10%. Then you go for charge. So that will use the shallow discharge, prolong the battery life. So that is the reason it will not put more stress on the batteries. I given the example of your work assignment also, right? So that it is very clear to you. The point is very clear to you. The shallow discharging and prolong life of batteries. All right. And also, if you think about the frequent deep discharging, right? The stresses of the batteries, the stress on the batteries, right, on the electrodes, right? That may leads to the premature of the capacity fade and also the power fade, right? So that leads to the premature of the degradations. So if you see the frequent deep discharging, right? Frequent you are going to discharge and charge that will stress the on the battery electrodes also, right? Frequently deep discharging should not happen, right? And also you cannot have the more stress on the electrodes, so that will lead to the premature of degradation. Also the concept of what is the concept we have studied, that is the capacity fade and the power fade, right? Capacity fade and the power fade. Here that is what we studied, the capacity fade and the power fade, which leads to the power fade and the capacity fade of the batteries if you go for the frequent deep discharging. All right. So let us see the charging methods, the various charging methods we have. All right. So we have the various charging methods. So one is the fast charging acceleration degradation by generating the excessive heat. Right. So how charging the effect will degrades if we make the very fast charging, right? If we make the degradation more faster. So what is the reasons? What are the factors? What are the factor which is impacting on the charging methods, right? Suppose if we charging, how the charging affects the degradations, right? The fast charging. If we make more faster and faster in charger, if we have nowadays we have the AC chargers also we have, which is introduced by the various industries. We have the DC fast charging also, right, for the AV vehicles. How this charging method will make a lot of impact, right? So if we make the fast charging, what will happen? The high current will comes, isn't it? And excessive heat will be produced, and the lithium platings on the anode, right, which accelerate the both capacity and the power more faster. It will try to feed, right? So commonly it will happens in the EVs, right? For especially in the DC chargings, right? DC charging is fast charging only, correct? DC charging is fast charging. If you make the charging method in the DC charging, right, it will charge very faster, right? So what will happen in the DC fast charging? High current it will come, correct? If we nowadays we have the mobile charger, the fast charger, it will charge in for 40 watts, 35 watts, like something 70 watts of charging, which is more faster, right? It will try to collect the heavy current. It will try to draw the heavy current. High current it will be drawn, right? And also meanwhile the excessive heat will be there, right? And the lithium platings, right? And the platings on the anode will try to accelerate both the capacity and the power to feed. So that is the reason that should not happen, right? So that is the reason for the fast charging, right? Fast charging accelerate the degradations also. please, in the DC charging also, when you go for the vehicle for the DC charging, so what will happen? It will try to degrade. It will try to degrade. The degradations will happen if you make the fast charging, because it is drawing the heavy current, right? If you take in your cell phone also, right? If you charge for, if you plug into the for 45 watt of charger, what it may be, right? It will charge within 30 minutes. It will charge in 15 minutes. It will take very less time. So what does it mean? That is what we have discussed in the C rate, right? That is what we have discussed in the C rate. See here, the C rate will tells charging of C rate of 1 coulomb. That is 1 hour 100%, right? For 2 hours, it may be takes of C by 5. Correct. If it is 20 minutes, for 100% is taking 20 minutes. It may be of 5C also. Correct. 5C, what is the meaning of 5C? That much of coulomb of charge is being stored, energy stored in the batteries, more faster and faster. Right. So that is what the C rate it will tells, isn't it? So that is what you have to think about the charging method. We should not go for the fast charging, right? Fast charging will makes to accelerate the degradation has very earlier, and it will try to generate the excess of heat also, right? So DC, we don't expect the DC fast charging, right? That's why it will try to draw the heavy current, and it will try to have the excessive heat also, right? And it will try to provide the yeah, high capacity and the power fed also. We try to accelerate the both the capacity and the power fed also, right? So these are the various reasons. And also when you talk about the overcharging, right? If you charge for 100, so for example, you charge for 100%, right? You are not plugged out. You are plugged in for long times, right? So what will happen? Again, it will try to get overcharged, right? When it will try to get overcharged, for example, if the cell batteries are on 4.2 volts, okay? Now take the cell batteries around 4.2 volts, right? So if it is charged for more than 4.2 volts, what will happen to the cells? The cell causes the electrolytes to break down. Yes or not? Means you are not to provide the over stress on the electrode. That is what I told on this frequent deep discharging stresses, right? So you cannot have the stress on the electrode, right? You cannot put the stress on the electrode. Don't put the much stress on the electrode. It will your electrode will get broken up. Understood? You cannot put the more stress on the electrode. See, it is very similar. It is very similar that if you can lift the weight of, if your weight is around 50 kg, weight around 50 kg, can I lift for 250 kg? Is it possible? It is not possible, correct? Because it is overweight. Yes, sir, it is overweight. More than your weight. 50 kg means you are lifting more than 200 kg of actual of your weight. It is highly impossible. Similarly, you should not go for overcharging. It will try to damage your electrodes. So please we have to keep in this in mind. Okay. So these are the very basic things we have to keep our battery, to increase our battery life, to overcome the degradations also, right? So again, when you come to the concept of the trickle charging, right? So trickle charging also one of the methods, right? Where you have the low current at the full charge, right? It will reduce the voltage stress, and also it will degrade. So that is the one reason. Trickle charging is also will have the low current at the fully charged, right? You will try to provide the low current at the fully charged, and you will try to reduce the voltage and stress, and also the degradations of the batteries by minimizing the voltage stress. So this will make the prolonged time for the 100% of state of charge, and also it will degrade the lithium ion batteries also. So these are the various methods. All right, these are the various methods to make the life of the batteries to be reduced, right? Because of the degradation, right? So we have to monitor the charging methods is very important. The state of charge and state of health. So we'll learn in the future. In the upcoming session, you'll understand what is state of charge, what is state of health. All right. So we'll learn in a very better way, right? The fast charging, how the fast charging is affecting on the degradations of the batteries, creating the excess of heat, right? See, heat is also excess, right? I have shown the temperature in the data sheets. It is around 25 to 26, right? Voltage is also increased. Right there, we don't have any voltage stress. We don't have on the stress on the battery electrodes. We don't have rise in the temperature, right? We are maintaining the battery temperature. Always we are maintaining the battery temperature, right? I've given the data to the machine. The machine is analyzing each and every data. It is trying to understand the battery conditions. Every single it is trying to learning the battery conditions. It is because we have trained the data for the machines, right? It is providing the exact data for every time. It is providing the actual data of the temperature, right? So we have to monitor the temperature in the state of charge. We have to monitor the voltage. We have to monitor the current. So these are the three major parameters in the charging methods, right? If you fail to do this now, obviously the degradations will happen. If you don't maintain the temperature, we don't maintain the voltage, right? So that is what I told you now. Voltage, when you talk about the voltage, the battery of the voltage is around say it is around 4 volts or 3.2 volts, right? So voltage which is the cell voltage is around 3 volts only, right? If it is greater than 3.5 volts, right? So what will happen? The cell will cause the electrodes to break down immediately. Okay, don't go for the overcharging. What is the reason to why should you go for the overcharging? Once it is charged, right? Sometimes it may give a signal to your EVs also, that is overcharge, or else we have to make the kind of the any system to make the people to understand the battery is fully charged. It has to give some alarm for the users. So overcharging, so that the people will understand how it is get overcharged. By if you don't use that kinds of the system, no, the people will not having any awareness. Right, they'll keep on plugged for many for long times, right? So what will happen, that leads to that if the battery is around 3.5 volts, it will, if it is voltage is increased to 3 to 3.5 volts, so it will affect on the electrodes. The electrode will try to break down. All right, so these are the various charging methods. Please follow the that's why the most of the industries they are going for the AC charging and the slow charging. All right, DC is a very fast charging for the EV vehicle, right? And you have to replace the battery once you take the car, no, electric vehicle car. After 2 years or 3 years, you have to replace it immediately, right? You have to replace your batteries immediately, right? We are not what, because battery is already I told the battery is the heart of the vehicles. Please focus more on the batteries. Battery management system is very important, right? Right, that is what we have to learn in the upcoming modules, right? So we are going to study the battery management system. We have to monitor the battery properly. If we don't monitor the battery properly, no, the health is gone, right? And the charging discharging system is gone, right? You cannot have the safety for the batteries, right? And you cannot you can have the thermal management also. The rise in the temperature in the batteries will also occur. So this is very interesting topic, right? So for that you have to understand the concept of degradations, right? Degradation is very important. All right. So these are the various things we have to understand the concept of the degradation, right? So charging methods. So please follow up these methods to keep your battery to be in the very safer conditions and give the prolonged life for the batteries also and have the good life cycle for the batteries. All right. So next is the life cycle of predictions of the batteries. How we are going to predict now? One is from the prediction from the battery management system, right? I have shown in the third chapter, right? We have to study the managing the battery conditions, all the conditions in monitor, right? So which will provide it will provide what is the remaining life, the remaining life for the batteries. It will tell how long it can come, right? We are just observing if the life of the battery is around 4 years, right? By using this system, we can make the predictions. We can understand the life of the batteries. How long it will come for? It will come for next 1 year. It will come for next 6 months. It will come for 2 years. That is what we are going to learn in the battery management system, right? So battery management system will use a very key functions. Key function nothing but it will give your all the various parameters of the BMS. The current, it may give the current also, it will give the voltage also, it will give the temperature also, as I given in the data sheet, right? So it is going to predict, every time it is going to predict. If the temperature rises gradually, no, from 25 to 50 degrees centigrade, then life is gone, right? So that's why you have to maintain, you have to monitor the battery management. It's very important, right? So there is a battery man in the battery management system. We are going to monitor all the various parameter of the voltage, current, and electrodes, and internal resistance, and also the temperature. We are going to monitor all these various parameters so that we can give the life for the batteries. If you don't monitor, no, for example, if you fall sick, no, if you don't consult the doctor, what will happen? All right. Hope you understood. What will happen if you fall sick? No, you have to consult the doctor immediately. Correct. So this is the reason. Or some other disease will again it will come. So multiple diseases will come if you don't consult the doctor for the first time, right? So that you have to recover back immediately, right? Your health has to be come back to the normal stage. So that is what you are going to monitor your health. Correct. You are going to monitor your health. That is what we are studying in the monitoring the internal distance. Then we'll go for the machine learning. Then we'll see the incremental capacity analysis also, right? So these are the various things. So for that we have to study. We are going to study in this module, right? The battery management system. So first we'll go to the architecture, and then we'll go for the state of charge, state of health, estimation techniques, and various mechanisms and the thermal systems. All right. So this is how we are going to make the predictions of the battery life. All right. So if you have any queries, you can ask me. Is it clear to everyone?
Yes, sir.
Uday,
Sir, yes.
Sanjita, Sanjita,
Yes, sir.
is it clear ma for you?
Yes, sir. Yes, sir.
So we'll study all these factors. I hope you are now very, you have learned the very basic fundamentals of the battery conditions, right? We'll study the in the upcoming modules. It's very interesting, right? Battery management system is very interesting. How you are managing your health now? That's why you have to monitor the health of the batteries also, right? So that is very interesting topic in the upcoming sessions. So if you have any queries, you can ask me with respect to your this module of this topic, right? If you have any queries, you can ask me. Right, we are in the end stage. Added degradations or at life cycle. Life cycle depends upon all these various parameters. We have to manage the BMS. We have to monitor the internal distance. Right, internal distance of the battery has to be monitored properly. We have to analyze from the machine learning. Right, various models. You take various model. You take the past data. You take the patterns of your cells. You take the environmental factors like various weather conditions or factors, and analyze the battery conditions. Right, make the prediction of the batteries of the health, how long it can retain with us, right? So these are the various predictions where you can going to have the life predictions of the batteries. All right. So if you have any queries, you can ask me. Shall I wind up the class if you don't have any queries? Because we are about to finish your classes. Yes, Uday, is the concept is clear?
Yeah, yeah,
Sneha,
sir.
Sneha, okay, Sanjita, okay, Rashmi,
Yes, sir.
is it clear, ma? Concept is
Yes,
clear to
sir.
you?
Yes, sir.
Okay. So I'll wind up the classes here.